Okay, looks good. Hey, good morning to all of you once again. So, in continuation to our previous session, here I am going to discuss majorly about what is current .NET. Yes, it all started with .NET Core. Sometime in the year 2016, Microsoft gave a revolution in the .NET in the form of .NET Core. And that is when actually Microsoft made .NET as open source, cross-platform. Actually open source it was with .NET framework itself few years back. Maybe I think in 2014 itself Microsoft declared that .NET is going to be open source, and they put the entire source code on GitHub with certain basic limitations. But with .NET Core, a new .NET Foundation was formed, a new body called as .NET Foundation, and that is the one which provided the entire contribution to .NET Core, which became of course a general purpose development platform. Entire source code was available. That means it is an open source, cross-platform. That is how it became not only on Windows but also on Mac and Linux. It was possible now to develop applications which will run on multiple operating systems. So like in the past, rather unlike in the past, when only Java was platform independent, now Microsoft can as well say that yes, .NET is platform independent. Not only Microsoft, there was community support coming up for .NET by Red Hat. We had Red Hat Package Manager, Debian distribution families supporting actively .NET. And not only .NET was supported on x86 and x64, which are majorly for desktop, but also by ARM, which was for, let's say, more of mobile and tablet kind of CPUs. Tablets and mobiles majorly use ARM processor. So these processors and of course the desktop processors, 32-bit, 64-bit, all started supporting .NET, and it provides the flexible deployment that can be included in your application or installed side by side. Basically, you can actually include the entire runtime along with your application and deploy, or you can make it as framework dependent deployment, self-contained and framework dependent. Two types of deployments were possible now. At the time of creating the package itself, we can mention, even if I do not have .NET runtime on the target machine, compile the output in such a way that all the dependencies required should be available for the target platform. So even if .NET was not installed on the target platform, just copying the packaged output would make the application work. That was something which was a beautiful feature added. So there was no separate need for installation of .NET runtime on the target machines. Extraordinary support came for containerization Docker, and we were able to create very small Docker images so that the same things can lead to massive microservices based application development. In microservices, we would like to have multiple microservices, like hundreds of microservices would be there. Now managing hundreds of microservices which are developed independently in different projects is going to be a nightmare if we do not think of things like containerization or orchestration. And .NET Core had an excellent support for Docker. .NET provides compatibility with .NET Framework and Mono API with the way .NET Standard specification was implemented. I'm going to elaborate more on .NET Standard in the later part of this session, but we wanted to share code. Now it's like this. Same vendor has .NET Framework, industry gave Mono, which eventually became 𝗙𝗏. And now we have got .NET Core, one more framework, one more runtime. So three things are there now which are supported by Microsoft. .NET Core, .NET Framework, and Mono API. Now how can I write code which I can use it in all the three places? Basically I wanted to write class libraries so that the same class library I should be able to use it in all the three runtimes. And that is when they evolved .NET Standard specification. So we started building .NET Standard class libraries. Instead of doing .NET Core class library, .NET Framework class library, Mono or 𝗙𝗏 class library, we started writing .NET Standard class library, and that would be compatible with all the .NET implementations. Something really worthwhile, going more into details in the later part of the session. But yes, this is how .NET Core evolved. Year 2016 they gave .NET Core 1.0. Again, not something which industry so soon accepted. I remember only from .NET Core 2.1 there was major acceptance in the industry. And of course 3.0, and finally they gave 3.1, which was a long-term edition, LTS edition. And with .NET Core we were able to build web-based applications. Was pretty much aligned to cloud, because by the time cloud was already popular. So if we wanted to build cloud native applications which can make use of a lot of cloud services, yes, these features were added into .NET Core, whether it is security services or whether it is caching services or the deployment integration along with Docker and Kubernetes. Everything was made much easier in .NET Core. They did have support for desktop based applications. .NET Core supported desktop based applications also, IoT device applications, and a big enhancement was AI features were added. Artificial intelligence libraries were provided. We would be able to do programming using Azure AI. The services on Azure, we would be able to use it for cognitive, we call it as cognitive services, basically speech services, text recognition services, image recognition services. All these services were pretty much available in Azure, and we can start coding them in C# in .NET Core. So these were the enhancements which were added. .NET Core by itself is a separate runtime. That means like we have got CLR in .NET Framework, .NET Core had Core CLR, and .NET Core had its own class libraries. That means it was an absolute parallel framework which was introduced. Parallel to .NET Framework, .NET Core was introduced. Code written in .NET Core was not probably compatible in .NET Framework, and vice versa is also true, except when we adopt something like .NET Standard. So when to use .NET Core? What was the recommendation? You wanted to have cross-platform applications which would run on Windows and also on Mac or Linux. Then we wanted to use .NET Core. We didn't have .NET Framework as an option. If your target was to build microservices based application, .NET Framework is pathetic. But .NET Core, the biggest advantage was it was having very small patch in memory. .NET Framework loads huge amount of code into memory. Lot of that code from the .NET Framework base class library which is loaded may not even be used at runtime by us. But that patch which is loaded by .NET Framework into memory makes the application heavy. Microservices were supposed to be multi-process, multiple instances running, and we cannot afford to have heavy payload. .NET Core payload memory utilization was very minimal, and that's why it was very much suitable for development of microservices based applications. And then the same microservices based applications we were able to containerize. That means we were able to build Docker images, deploy them into the container registry, Docker container registry, and simply use them for deployment of application. That on the target machine where we want to run our application, if there was only Docker support, our .NET Core applications would run. Because the Docker containers themselves would contain entire dependencies which are required for execution. So the huge difference between .NET Framework and .NET Core was .NET Framework images were pretty large in size, very large in size. So if they had to be downloaded from the registry to the local machine, that would take huge amount of time. Internet bandwidth, of course, will be a deciding criteria, but on a normal speed also, they would take lot of time to download as the size was huge. Whereas .NET Core images are much smaller in size, like 200 MB. .NET Core images 200 to 250 MB. Of course, it again also depends on how much code you might have added, but regular .NET Core images, base images at least to a 200 MB. On top of it, how much code you have added, what data you are carrying, that would only decide, but that's much smaller when compared to .NET Framework. So containerization was very much important while giving .NET Core to the industry. Enhancements were done to the performance of the application. Microsoft worked on their APIs itself in such a way that without we doing much, the application gave better performance. And because I told you the patches were small, it was much easy to do scaling of application. And then a new way of altogether building the applications came in, that is CLI. We don't have to now create project using something like Visual Studio, where the project file is huge. The solution file is huge. Now we started building applications using .NET CLI, command line interface. Like always Java gave this feature. We used Java and Java C. Like that now we used in .NET CLI, using which we could create projects, using which we could add dependencies, using which we could ensure that tools are downloaded. .NET CLI can be used for building the project. .NET CLI could be used for restoring the libraries, which were NuGet libraries. .NET CLI could be used for packing the project so that we can deploy into NuGet. .NET CLI could be used for publishing a project so that published output can be deployed onto the target machine. Basically, if you are doing some basic simple job in .NET Core, you don't even need to have something like Visual Studio. You can start free. Just download .NET Core SDK on your desktop and download VS Code, and you would be able to achieve most of it using these two things only. Of course, Visual Studio .NET, if you are using, it's going to make you more productive, especially for large applications which you are going to develop. But that was not a desperate need. I don't remember any time building .NET Framework based applications without Visual Studio .NET. The very basic Hello World application also, I would use something like Visual Studio .NET for building .NET Framework based application. Or a simple single page website also, if I have to develop, I have to use Visual Studio .NET, which is pretty heavy, expensive, not cheap. But basic development now we can do it with the CLI. This was a big introduction. So of course, even today CLI commands are very popular. Rather, every technology now has started providing CLI because they want to integrate pretty well with Linux. And Linux not necessarily should have a UI of its own. Linux servers especially will not have any user interface. We will have to operate from the CLI only. We can't run something like VS Code or Visual Studio in a Linux server which doesn't have a built-in UI. You have to install it explicitly separately, but otherwise Linux, Unix, they don't have UI of their own. So CLI is the only option at that point of time. .NET Core also gave support for building now Windows Forms applications and WPF applications. You could continue your desktop based application development using .NET Core. And for client side, we had got Blazor. Blazor was something introduced for client side. So what is Blazor? We'll discuss shortly. But yes, all these are the new things which .NET Core facilitated. Now what was removed? Web forms, which I now call it as legacy style of web development. When .NET Framework was introduced in the year 2002, major contribution was in form of web forms, the ease with which we were able to develop web-based applications. So prior to that, it was classic ASP. Classic ASP, as I told you, 5 or 6 objects we had, not more than that. And from there was a huge radical change in ASP.NET Web Forms. The idea behind Web Forms was to make Web Forms as similar as possible to WinForms and be able to develop web-based applications. We would be able to make UI with drag and drop, and then that would render HTML output to the browser. Web Forms was good for a very long period of time. But with time, the client-side technologies became pretty popular. When Web Forms was evolved, at that time we had simple vanilla HTML, we had basic CSS, but with time HTML5 came up, CSS3 came up, people started expecting a lot of dynamism on the web pages. Dynamic HTML was something which was the basic need of the industry. We wanted to have interactive web pages. Web form was doing everything on server. But now the browsers became powerful and we wanted to exploit the power of the browser. Web forms were not suitable for that kind of architecture or feature. They were not architected only for that browser capable features. We would do some basic JavaScripting, but not too much, because the client side output which was generated by web form was very native to the controls which we are going to make use of on the server. Like we had a grid component on the server. The grid component can generate table tag to the browser, and table itself was outdated when browsers became powerful. We wanted to build web pages which would automatically adjust to the devices, which can be tablets, mobiles, desktops. Responsive web pages we wanted to develop. And in responsive web pages, we don't use table tag. So we wanted to have huge amount of customization in the browser. And that feature was a limitation of web form, and that's when people moved from web forms to MVC, Model View Controller Architecture. And Model View Controller Architecture again was majorly initially contributing to server-side components, Razor pages they called it, and the Razor pages were rendering output which was more of HTML friendly, and we would be able to customize it a lot using JavaScript or maybe TypeScript on the browser. But as the time progressed, people moved away from that also. They stopped using server-side strength of ASP.NET in the form of MVC, the view, model View they did not want to use. They continued using view modal, they continued using controller, and for Vue, the entire industry started moving towards Angular, React, these kind of technologies, client-side frameworks, which were making the web pages very dynamic without making lot of trips to the server, was the need of the hour. So what happened here? The whole industry moved from web forms to web API on the server. See this transition. Of course, web forms to MVC to web API on the server, and on client side they started making use of a React, initially React.js, then it became React Native, and then also side by side Angular.js, and then it became Angular, and there were many other libraries or frameworks which were supported, but these two became pretty popular on the client side. Today, most of the web-based application development would use Angular or React on the client side and web APIs on the server. So there was absolutely no need for web forms as .NET evolved. WCF, Windows Communication Foundation Services, were not supported in .NET. Now why they are not supported? WCF were majorly for building SOAP based services, Simple Object Access Protocol. SOAP was entirely dependent on XML, and XML messages would be transported from client to server and server to client. XML itself is heavy. XML is verbose. That was one major problem, especially when the clients are mobile devices, which initially at least had a lot of bandwidth limitation. See, today we are in the era where we are not really worried about internet bandwidth, internet speed, but I'm talking about the early days of this century. We really had huge amount to pay for internet bandwidth, and internet speed was not as it is today. So that time we definitely had a concern of volume of data which is getting transported from server to client or client to server, and in case of WCF it was heavy. The entire industry moved from SOAP based services to RESTful services, and RESTful services were developed using ASP.NET Web APIs. So even WCF need was not so much there at that point of time. Most important, WCF was also used for building native APIs, which would again be supported in .NET only. Server side APIs are in .NET, client side development also you may have to develop in .NET. Though WCF did support RESTful, it was not that friendly or easy. Web APIs, the alternative option, became default standard after some years for development of any kind of server side API. So at least Microsoft did not feel the need for providing support for WCF in .NET Core, and that they eradicated. Obviously, now we do not have support for writing to registry. Earlier days, I still remember when we used to do programming in COM/DCOM. The major limitation was COM/DCOM components were supposed to be registered on Windows registry. Simply copying the file onto the target machine would not be sufficient. I have to go to that machine and explicitly log in as administrator and register the COM components, and then only they would be functional. Otherwise, no. That problem .NET eradicated, no doubt. In .NET, we did not have any requirement of registering components in Windows registry, but they still they still gave support for ability to write to the registry or read from the registry, which eventually over a period of time the approach died. People started replacing registry with own custom files. Configuration files became more popular. So all this VMI, WMI, Windows Native Integration, all these libraries were not supported in .NET Core. So what is important is what is not supported in .NET Core and how Microsoft got rid of them. In addition to, of course, what is supported in .NET Core. So .NET Core had web, cloud, desktop, IoT, AI. I always hated Java because the way Java was supported on different platforms by different vendors. IBM gives support for Java. Sun Microsystem, the original founder, now eventually took over by Oracle, they support Java. Linux, Red Hat had their own support for Java. So many frameworks for building web-based applications in Java. We used JSPs, we used servlets, we used EJBs at some point of time, and then it went on to building microservices using Spring, Spring Boot. Oh, so many frameworks. And now Microsoft started following the same path. We now are confused industry again. Microsoft was consistent. .NET, 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 .NET. That time when we said .NET, it was .NET framework. Now we have parallel .NET Core. Confusion. What to use? .NET Core should I use? .NET framework should I use? .NET Core definitely had a good amount of learning curve because it was new. Industry support was not that very good because not many blogs were existing, not many solutions to the problems would exist. It was very naive. But there was a future. Microsoft knew this is the route they are supposed to take. So these are the different devices, platforms on which .NET Core was supported. The list was big, maybe few more. I just recognized these, but there can be few more. Definitely Windows Server, Windows Client, Mac, Red Hat Linux, Fedora, Ubuntu, so many different editions of Linux. Not only that, .NET Core was also supported on IoT devices. There also .NET Core had the support. I did not document that here, but yes, even there we had .NET Core. .NET Core big contribution, especially the 3.0 version of .NET Core, gave Blazor to the industry. Microsoft started concentrating on the power of browser. So they gave Blazor, which became a very good substitute to using Angular or React. Angular and React, we had to always program either in JavaScript or TypeScript. That means developers had to learn one more programming language. I know C# for building server-side applications using ASP, but now I have to learn JavaScript. I have to probably alternatively learn TypeScript and then build client-side applications using either React or Angular. And the client-side applications would talk to the web APIs which are on server and they have to be written in C#. That means now we have got multiple programming languages, a need for more than one programming language. What to do? Microsoft found a way out. You can now do coding in C# to build interactive web UI. Interactive web UI, that means nothing but what we could achieve using Angular, using C# instead of JavaScript and TypeScript. It enabled client-side web application development. My code will now execute in the browser using something called as web assemblies. I will program it in C#, create a web assembly. The web assembly will execute in the browser and give the same result what one would get in Angular or React. In addition to that, they also supported programming it on the server side. The end result would be same. They used Signal R, which was built on top of web sockets. See, HTTP protocol is pull based. Using HTTP, we can only pull the content from server. SignalR, which is built on WebSocket, is reverse mechanism. Server can push content to the browser. On the browser, the code is going to execute by calls from server. So SignalR gives something like near real-time effect to our application. What happens on server, we don't have to poll. The server is going to notify us to the client side. And we don't have to do direct SignalR programming. In background, it used SignalR to update the browser. Of course, the browser should be WebSocket compatible, but all modern browsers are definitely WebSocket compatible today. We don't have this history. I mean, decades back it started supporting it. So now the new versions are definitely having support for SignalR. So you can do server-side programming. With the help of SignalR, the browser pages would get updated. Or you can simply do client-side programming. Code executes on the client in the form of WebAssembly. So both server-side and client-side. The applications run on the client using WebAssembly, providing rich user experience. Server-side, you communicate with the client using SignalR. So that's the advantage which we got here with Blazor. So Blazor was an introduction in 3.8. Today the Blazor is used a lot. A lot of people who are who wants to stick to only one programming languages, don't want to deviate from one programming language, have adapted Blazor. Definitely it has not become as popular as React and Angular, but still it is an option which people are looking at. And Microsoft, we all very well know, they give something not going to be very popular initially, at least. Eventually people will not be left with choice, they will have to adapt it. So still that acceptance of Blazor is not as much as it is for React and Angular. But over a period of time, yes, they will improve the technology in such a way that we will start adapting it. So how was the confusion removed? Now I have two frameworks, .NET Framework up to 4.8 and .NET Core 3.1. Now I am confused. While I am developing applications, should I go for .NET Framework? Should I go for .NET Core? Microsoft decided they are not going to further enhance .NET Framework anymore or .NET Core anymore. They took the root of .NET Core. They took .NET Core as the base and they skipped after 3.1 version 4. .NET Core version 4 was entirely skipped. And they said now it is .NET 5. And they said .NET 4.8 has freezed. No more enhancements to .NET Framework. In whichever form it is right now in .NET Framework 4.8, use that in case you want to. But all new growths and enhancements and features, further development is only and only going to happen in .NET. They changed from .NET Core to .NET. So they called it as .NET 5. They didn't call it as .NET Core 4. Just to bring the consistency in the version number. But remember, .NET 5 is nothing but an extension, additions on top of .NET Core. .NET 5 took the root of .NET Core and not .NET Framework. They skipped 4.x so that you don't get confused with .NET Framework. So .NET 5 supports more types of application. Whatever applications were supported in .NET Core, in addition to that, more application developments were possible now in .NET 5. More platform support for .NET Core. .NET 5 and above, whether it is .NET 6, 7, 8, every 2 years now Microsoft is going to release a new version of .NET. So rather every year, not even 2 years, every year in November. You see, almost same timeline. Every year in November, they are going to release a new version of .NET. .NET 5 was there for a short period, immediately replaced by .NET 6. People use .NET 6 more because it's a long-term edition, LTS. LTS editions are guaranteed to stay for at least 3 years. Microsoft is going to give support to .NET 6 up to 2024. 3 years on top of this. Then they have .NET 7, which they called it as standard term support. They did not call it as LTS. They called it as standard term support, STS. Not necessary that should be supported for 3 years. But then again, .NET 8, which is now going to become the final edition currently, is going to be a long-term edition supported for 3 years again by Microsoft. So after .NET 8, .NET 6 would be supported for a year, but when .NET 9 comes, 6 is going to go out of support. They will not enhance or support applications in .NET 6. So yes, we have to upgrade. We have to continuously keep upgrading our applications from .NET 5 to 6 to 7 to 8 to 9, and it would go on forever like this. With .NET 5, the biggest, and of course the later version, the biggest advantage is you now think of doing development using .NET. No confusion. You target your application only and only for Windows or not. You can definitely use .NET 5 and above. So Linux, Mac, iOS, Android, TV OS, Watch OS, and of course the WebAssembly. Everything now they consolidated into a single version. So now we can do cloud-based application development, heavy cloud-based application development. Today, if you are a .NET developer and if you do not have knowledge of cloud, you are incomplete. So much of development is happening in cloud services, using cloud services. You might, for security, simply integrate with Azure Active Directory, which can be B2B directory or which can be B2C directory. But integrating with Azure Active Directory can ease most of your things, and you have to only integrate. You don't have to develop authentication and authorization module. Just imagine. ASP.NET has now become ASP.NET Core. Forgot to mention, with .NET Core up to 2.0, up to 2.x, we had option of building web-based applications using ASP.NET Core. But ASP.NET Core itself had an advantage of either using .NET Core or using .NET Framework. Something funny, but listen to this. With .NET Core, Microsoft came up with ASP.NET Core for the application development, web-based application development, web MVC or web UI. And then they also introduced something called as Razor Pages. So whether we use MVC framework or we use Razor Pages framework or we do web API, in all the three cases, when .NET Core was supported, we had in ASP.NET Core two options. We could use .NET Framework and ASP.NET Core, or we could do .NET Core and ASP.NET Core. If I wanted to run my ASP.NET Core applications on Linux or Mac, I would definitely use .NET Core Framework only. But if I would run my ASP.NET Core applications on only Windows, I can take .NET Core and I can also take ASP.NET Framework. Either of these two I can use for development. This facility was given because .NET Core was not very matured. There were lots and lots of class libraries which were not supported in .NET Core initially. The base class libraries I'm talking about, which is basically the crux of application development on which we are dependent on. There were a lot of classes which were not supported in .NET Core initially. Gradually, Microsoft kept on upgrading .NET Core, and today, of course, with .NET 5, when we do ASP.NET Core development, we use only .NET Core. I mean, of course, the .NET Core replaced with .NET. So from 3.0 or 3.1, one of these two versions, I think 3.1, they stopped supporting .NET framework for ASP.NET Core. No more .NET framework for ASP.NET Core after 3.1. So this is what has evolved. ASP.NET Core today is ASP.NET Core. Listen to this. ASP.NET Core stands as ASP.NET Core only, but when we use .NET, ASP.NET Core 5 will use .NET 5. ASP.NET Core 6 will use .NET 6. ASP.NET Core 7, 8, respective version of .NET they use. Because it's all common now. It's just .NET. Whether it is cloud or web-based applications, this is ASP.NET Core. It is no more plain ASP.NET. So when we say ASP.NET, we actually mean ASP.NET with .NET framework up to 4.8. ASP.NET Core after that with .NET. Blazor is also web-based. Server-side components can be written. .NET MAUI is now introduced. WPF was always there. WinForms was always there. Mobiles can also use MAUI now. Xamarin is on. So now MAUI. What is MAUI? Multi-platform application user interface. There is multi-platform. Application UI is a cross-platform framework for building native mobile and desktop applications with C# and XAML. Most important is it unifies and replaces technologies like WPF, UWP and Xamarin. You can literally, again there is a big confusion. Should I use WPF? Should I go for UWP? These are for desktop, this is for mobile. So I have to build two versions. For mobile separate version, for desktop separate version. Why all this? Simply get rid of all this and standardize on MAUI, multi-platform application user interface. XAML is same, and you have very similar. Somebody who has done Xamarin development will not find a lot different when they move to MAUI. You can run on Android, iOS, Mac and Windows. All UI. We didn't put Linux there. Linux is not for UI. Linux is supposed to be used for server side. From a single shared code base. This is the most important part. Your code base is only one. You create only one project. You compile it for the respective operating system. And not only that, if you want to exploit certain features of Android, you will be able to. So there are platform specific source code also which can be added. You can do conditional compilation. Through conditional compilation, platform specific code can be added to exploit the power of that particular platform or device. So that's what is the biggest advantage of MAUI. And MAUI of course came up with .NET 6. It was not supported in .NET 5. So this is more .NET latest version. Unity is the framework which is used for building games in .NET. Has been there for quite some time. IoT devices, ARM32, ARM36. You can write applications which are ARM processor compatible and run on IoT devices. AI, your ML, machine learning, .NET, entire library of machine learning. All those machine learning packages, algorithms are ready-made implemented. You have .NET for Apache Spark now for heavy processing. So .NET has support for all these applications. Common base class libraries or APIs which work on the infrastructure. Yes, every library now comes through NuGet packages. Actually, this was another enhancement in .NET Core. In .NET Core, the way we started adding dependent libraries was from a gallery called as NuGet. So a .NET Core developer would build a class library, and when it wants to share with others, the class library will be packaged and deployed into a NuGet gallery. From NuGet gallery, we would refer to the package and use it. So now, any third-party component, rather components by Microsoft also, which I wanted to include in my development, I would simply go to NuGet package and add the reference. Even the core libraries were available in the form of packages through NuGet store, NuGet gallery. So that was a big enhancement in .NET Core, heavy dependency on NuGet. So NuGet is something which is very important. GitHub, you have the entire source code present. You can put your code into GitHub easily. Component tools and library vendors, everything is available. For development, we are going to use Visual Studio. Visual Studio for Mac is now there. On Mac, you can do active development of .NET. Proper Visual Studio is there on Mac. You have got VS Code and CLI, as I told you before. These are also very good options for development of .NET applications. Now, what is that .NET 5 had extra over and above 3.1? 3.1 had limitations. They said no to WCF. .NET 5 said, okay, we don't have WCF, but let us support WCF by way of open standard called as Core WCF. They made WCF open now, open source. So Core WCF is supported in .NET 5. So if you had WCF projects created in .NET Framework, and if you are migrating to .NET 5, only then you should go for Core WCF. But if you are building something new, instead go for gRPC. Don't go for WCF for scratch. Ideally, REST API. No, you don't want to go for REST API because that is mostly text-based communication. Then in such case, you would go for gRPC. It is paired with C#9 language. .NET 5 has come up with C#9. And then we have records concept, like we have got classes, we have got structures. Now there is something called as records which got introduced in C#9. Properties, we marked it as init properties. We have get properties, set properties. Now there is something called as init properties. Pattern matching was enhanced. We could use operators in the pattern match. We could use less than, greater than. These things can be used in the pattern matching. A big enhancement called as top level statements. We don't have to write now anymore class, program, static, void, main. Entry point method doesn't need to be written at all. You can directly write the code in the file itself. There was lot of source auto-generated. You just write some code to optimize the code which we have written. Source generators would automatically generate code for optimization purpose. Single file apps concept was introduced. App trimming was introduced. All this we are going to see later. So these are .NET 5 enhancements. And what did .NET did not support? Web forms gone. Windows workflow gone. From .NET Framework 4.8, which supported these two, if you move to .NET 5, you will not find support for these two. ASPX gone. It was gone actually in .NET Core itself. But if you are taking the route from .NET Framework to .NET, you will not see web forms. You will not see Windows Workflow Foundation. Instead, we have a lot of alternative options, like in cloud we have got logic apps, or you can write durable functions in function apps. So many other alternatives are provided which we can use for doing the same thing what we otherwise did with Windows Workflow. .NET 5 further evolved to .NET 6. They paired it with 𝗙10. Major advantage was .NET 5 to .NET 6, huge amount of performance improvement. The base class libraries were enhanced. Performance of the application would improve when done in .NET 6. Rather, this happened from every version of .NET I observed. From .NET 1 to 2 to 3 to 4 to 5. Every version Microsoft kept enhancing the performance of the base class libraries and thus the overall runtime. New features in the C# language. ASP.NET came up with a minimal API concept. You don't have to write lot of code. Reduced code you can do now. Especially targeting microservices based application development. With least amount of code you would be able to build APIs. So minimalistic APIs, web APIs, where we had to write the class and inside the class lot of methods, and the methods would have different types of attributes. All that they reduced a lot. Of course, coding reduced, ultimate result is same. The number of lines of code which we would write, that has reduced in ASP.NET Core 6.0. Visual Studio 2022 came with 6.0, and this is again a big revolution. Visual Studio, one big enhancement is it is AI integrated. It's an intelligent tool now. You write partial code and it will write the entire code for you. It will project certain statements for you. You declare 3 variables, integer, n1, n2, n3. How people have used these 3 variables, n1, n2, n3, based on that code will be automatically projected and given to you. So lot of reusability, your coding will become easy. Hot reloading was one big enhancement. You can just make changes to the code and reload it. You don't have to stop debugging and start debugging. The update to the code will apply then and there, and you can continue your debugging session. Through CLI, we can achieve the same using .NET Watch. Intelligent code editing, robust diagnostics and testing tools were added. Better collaboration with team, and of course, mouse support is one which is added to the Studio 2022. So this came up with .NET 6. MAUI is purely with .NET 6. .NET 5 did not support MAUI. Till then we were using only Xamarin for mobile and UWP for Windows, or some people still continue to use WPF. So now you see iOS, Android, Mac, Windows all under one umbrella. So life is easy now. You want to do Windows kind of application development, desktop based application development, MAUI. Web application, ASP.NET Core. Simple. .NET 7 again focuses on unified, modern, simple and fast. Unified, bringing everything, more and more support for the language, for multiple types of applications. Will be supported for 18 months only because standard term support it is. Earlier they called it as current release, now they call it as STS. Is paired with 𝗙_11. String handling became much easier. There was one more modifier added now, required. Anonymous structures and union features is added. There was improvement in CLI, .NET new command. Lot of templates were added for creating different types of projects. You would be able to build containerized version of your application using .NET Publish. .NET container integration is easy now. And then .NET 8, which is on the cards, is supposed to have .NET 12, improved support for cloud native applications. Source code generator enhancements are going to be seen in .NET 8. And of course, it's still an ongoing process, something which they'll continue to evolve. Right now it is in the, as I'm doing this session, .NET 8 is not yet released. It is going to be a long-term edition. Will be sometime in November only they are going to release this. Huge amount of features. Actually not only .NET, a lot of my notes I have compiled from here. A lot of content I have taken from here. So .NET 8 is what we are now going to use for development of all our applications. That does not make .NET 7 outdated or .NET 3.1 or your knowledge of .NET 3, .NET 4 is not going to get outdated. They kept on improving it. C# is going to remain C# for the basic development always. As far as I understand, not many enhancements actually happened into C# at the IL level. See, they only kept on making language easy so that the developer can write less code. But what we were doing in the past, we are going to still do the same thing. With less code, we will be able to achieve it. For example, a is less than 5 and a is greater than 10, or rather or, if a is less than 5 or a is greater than 10, I would write like that. Now I would say a is less than and greater than. I don't have to use a again and again. This kind of simplicity they got into the language. From the time C# evolved, I remember generics was something which was introduced. C# generics, which was a big enhancement. LINQ, language integrated query, which was a very big enhancement. But language integrated queries were also nothing but ultimately what we would do with arrays and collections. They made it easy. Generics was absolutely new. Generics did not have history in the past. We were not able to achieve what generics in C# could achieve from 2.0. And then we have 𝗙𝗏, which is nothing but multi-threading. Task parallel library, multi-threading. We could still achieve it by writing code with threading API, but it's complicated. With task parallel library, 𝗙𝗏, the async and await keywords, things have become easy. People started adapting those things quite easily. That's how C# language kept on evolving. We are able to write getSet properties, and I want to probably initialize the property only in the constructor. we have now init properties concept. It's not that init property gave a new feature altogether which was not possible in the previous versions. No. I don't recognize a lot of features of C# today which were not possible in previous versions. The features of C# language are only getting enhanced to reduce the number of lines of code one would write, to make the feature simpler so that in routine we can start adapting it. Today I can do strings. I can put 3 quotes in the beginning of the string, and within the string I can put new line characters, I can write spaces, I can write multiple lines, special characters can be used, and then again I end with 3 quotes. So a string can be split into multiple lines and enclose it in 3 quotes and put whatever you want within that. So these kind of enhancements are what we have seen in the language. Now, the session would be incomplete if I do not focus on what is .NET Standard. .NET Standard is a formal specification of .NET API intended to be available to all .NET implementations. All .NET implementations. That was actually the base. See, .NET Framework, we had one base class library. .NET Core, a different set of base class libraries. Xamarin had got its own base class libraries and not compatible with each other. And same thing would be a problem if I write my class library. I build my own class library with reusable classes. It would work either in .NET Framework or .NET Core or Xamarin. It would not work in all the 3. So Microsoft desperately needed something which will work in all the 3. And that's how they came up with .NET Standard Specification. So this unifies .NET platform and prevents future fragmentation. Now what .NET Standard said? .NET Standard evolved again version by version. .NET Standard 1.0, 1.1, 1.2, like that. It went on to 2.1 and 2.1 they freezed it. So .NET Standard said these are the functionalities present with every version. A set of library contracts. .NET implementation must support each contract fully or not at all. These features must be supported or they shouldn't support. So using .NET Standard, suppose I'm building a class library and I say .NET Standard 2.0. All the functionalities must support the specifications of .NET Standard. So how it actually worked, I'll tell you. Suppose I use .NET Framework for development of my application. And I know I'm going to use .NET Framework 4.5. To get all the functionalities of .NET Framework 4.5, rather to make use of our class library developed using .NET Standard 1.1, I have to use at least .NET Framework 4.5. I cannot use .NET Framework 4 and expect my class library to be used. But as you progress towards right, what you notice is, say for example, I used .NET Standard 2.0 for building my class library, or I used .NET Standard 2.0 libraries of Microsoft. And if I want to do development in .NET Framework, I cannot use less than 4.6.1 version of .NET Framework. Or .NET Core 2.0 is minimum. And .NET Framework 5 supports all of them. All these are supported by .NET Framework. So, if you are building a .NET standard library, try to always use lower version of .NET standard so that it becomes compatible with multiple .NET implementations, lower versions. So when you write code, possibility is there, your code is not supported by .NET standard 1.1. You use a feature which is not there in 1.1. Then you change it to 1.2 version of .NET standard. Then you change it to 1.3 till your code compiles. See this. You can use this table to understand what is the highest version of .NET standard that you can target based on which .NET platform you intend to run on. If you want to do .NET Framework 4.5 and .NET Core 1.0, you can at most target .NET Standard 1.1. You cannot go to .NET Standard 1.2 because 4.5 is not supporting. 4.5.1 you will have to use. So this is the approach. When you choose .NET Standard version, you should consider this trade-off. The higher the version, the more APIs you are going to get. .NET Standard 2.1 will give you more APIs which are compatible. But what is the problem? .NET Standard 2.0 will not be compatible with earlier versions of .NET. The lower the version, the more platform it implements. The more platform implements it. This is the problem. So what is the recommendation? Recommendation is to always target the lower version of .NET Standard if possible. Target the next lower version of .NET Standard and build your project. Let's say you started with .NET Standard 2.1. When you build a class library, you choose .NET Standard 2.1. Write the entire code. Fantastic. Now try to build that using 2.0. If the code compiles, okay, go to 1.6. If the code compiles, go to 1.5. Somewhere the code will stop compiling because that feature is not supported in that particular .NET Standard version. That time you stop. The lower the .NET Standard version, more the number of frameworks which are supported. But what .NET 5 did is, .NET 5 adapts to the different approach to establishing uniformity, and this approach eliminates the need for .NET Standard in many scenarios. Now you don't need .NET Standard anymore. Today if you are building .NET libraries, use .NET, don't use .NET Standard. We don't have further enhancements. .NET Standard freezed at 2.1. Of course, if you use .NET Standard 2.1, your code will still be compatible with .NET 5, .NET 6, .NET 7 and all the versions after this. The primary substitution vehicle for .NET Standard reference is NuGet packages. So whenever you are taking any NuGet package, check is it .NET Standard or not. If it is a .NET Standard, you know it is going to work in so and so framework versions. So .NET Standard versions are backward compatible. That means Standard 1.0 libraries run in Standard 1.1 platform and higher. There is no forward compatibility. That's the problem. 1.0 libraries cannot reference targeting .NET Standard 1.1. So when you're doing .NET Framework, we have got target framework monikers now. These are all .NET Framework monikers, and these things we are supposed to specify at the time of creating the project. In the project file, in the .NET CS proj, which we are going to create, we have to specify what is the target framework we are going to build our application for. So if you are building for .NET 6, then you know which version of .NET standard you may want to use. You can use the latest .NET 2.1. But if you have built .NET class library, which is .NET 6, then it is compatible with this. But if .NET class library with .NET 5 is built, sorry, .NET 6 is built, it cannot be used with .NET 5. I repeat this point. If I have used .NET 6 class library, I take a class library project and I mention target framework as .NET 6. That class library, I cannot use it in .NET 5, but I can use that class library in .NET 7 and .NET 8. This is important. Forward compatibility. .NET 5 able to use later versions of .NET is not there. Backward compatibility. .NET 7 using the class library of .NET 6 is there. So no more .NET standard is going to grow. If you're building a .NET standard class library, this is supposed to be your target framework moniker. We call it as TFM. TFM we call it. Target framework moniker. The value of this is supposed to be part of your framework. Actually, you can have in target framework multiple values mentioned. I can mention .NET 6 and I can mention .NET comma, and I can also mention something like .NET standard or .NET core. I can mention one of these also, .NET 3.1 or .NET framework. I can mention like that. Multiple values I can mention. I want to compile it for .NET 4.8 and I want to compile it for .NET 6. So two folders will get created when you build your project. One folder will be compatible with .NET 6, the other folder will be compatible with .NET 8. And developers can use conditional compilation based on which they can decide if it is .NET 8, this code should be called, and if it is .NET 6, this code should be called. There are certain things which have changed from .NET 4.8 to 6. We don't use them anymore as it is, we change them. So you will see that is what is going to happen. And moreover, .NET 5.0 Windows, you can be very specific. Monikers are there for Windows operating system. So .NET 5 code, .NET 5 replaces both .NET Core and .NET Standard TFMs. We don't use .NET Core, we don't use .NET Standard anymore. If you are targeting development from .NET 5 and after, use .NET 5. Use .NET 5.0. That will be supported by all the versions of .NET. I mean all the subsequent versions of .NET. So this is how the technology is evolving, continuous process. But good thing is now there is a stability in the way we have to think. Today we are going to develop all these types of applications which we started discussing in the list here, and we can simply be happy saying that we are using .NET. No more .NET framework, no more .NET standard, no more .NET core. It's all .NET and ASP.NET core which is going to go forward. That's all in this particular session. Thank you. I'll take